Welcome back to Data-Driven Engineering. In this exercise, we're going to be talking about cloud computing, cloud data storage, and cloud access. They're important parts of data engineering to enable data aggregation, storage retrieval, and enterprise scale-up. So we're going to talk about ways to do that. We have three of these largest service providers as Microsoft Azure, the Google Cloud Computing platform, and then also Amazon Web Services, or AWS. So we have some equivalents here in terms of servers and containers, data storage, and these just have different names with these different providers. We also have network and then security and authorization. So let me review a couple of those with you just to start. So if you need computing, such as things like CPUs or GPUs, all right, you're going to use likely something that's going to be here in the servers or containers area, where you can deploy a container and then have it run automatically in the cloud. Okay, and it scales up. So if you need something that you maybe are just testing yourself, you can do that on your own computer. But let's say you need something that can scale up at certain times of the day to 1,000 or 10,000 or 100,000 users and be very flexible and elastic. Then that's where these virtual servers or serverless computing. Virtual servers are, you have it kind of a designated part of one computer. Serverless computing, it just spreads the load across many devices. And then the Kubernetes is a very popular platform for managing these servers, where you can spin up or take down a server very easily. So data storage is when, so this is servers and containers. Data storage is when you need to store data somewhere. And so you have things like objects, files, blocks, and you can also have relational SQL databases, or the NoSQL database, which is more flexible for some of the web applications and some of the other things that you want to store for more flexible applications and can be stored in an SQL table. So we also have virtual networks and content delivery networks as well under the network area, and then security and authorization. DNS is going to be, if I type in a name, it's going to look up that name and look up the address, so it's it can direct traffic to the right place. We also have authentication, authorization, key management, network security. Okay, so all of those, when somebody wants to log in, who has access to what data, to what computers, how to authenticate and give them access. So all of those are also web services as well. So if we look at developing a cloud client, this might be a web browser, a mobile app, some kind of IoT device, or other type of computer, microprocessor, something that's going to be communicating through the internet to one of these cloud applications, where the computing necessarily can't necessarily be done on that device, on a cell phone or in the web browser, or maybe there's some kind of aggregation like data where you're storing things in the cloud. So at the top level, you have software as a service, and that's your cloud application, like a server of some type that can receive that information and also produce results. So that's like a customer relation management, web conferencing, group chat, email, virtual desktops, and games, especially multiplayer games. All right, and then you have a platform as a service. So that's the application runtime database web server. And a lot of times, people who develop on the platforms as a service, they're not even aware of where the computing is taking place, or it's just this. It's a resource that they can use. Okay, a place where they can store data, where they can. So a lot of that is abstracted away, so that you don't have to worry about it. And that's abstracted away because of this infrastructure as a service. So these are going to be virtual machines that are just a resource allocation of one machine. Okay, or bare metal servers. That's where you get the whole server. Okay, or you also have these load balancers, networking. Okay, and then you have also the deployment model about how that gets deployed. So that's going to affect things like, do we need just a single server? Do we need to scale up and down based on large number of users, etc. So all of that comes into play when you're designing this cloud client. You want to be thinking about what kind of resources do you need, especially as you scale up. All right, so let's go through an activity where we actually create something. We're going to do something on a local computer just to monitor a web folder and be able to remove the background. So for example, here is a photo, and I want to be able to remove the background from this automatically. So I'm going to use this package, the REMBG, and it's very easy to use, but it also downgrades some of your Python packages with at least the current version. It requires some earlier versions. So I'm going to set up a virtual environment. These are instructions right here for Mac OS or for Linux. I'm going to do this demonstration with Windows. All right, so and then we're going to deploy this service right here where we're basically just one line, remove from the input. It's going to give us an output image, and but we want to be able to monitor a folder or set up a WebSockets type web API so that another service, another client can request that you remove the background from that image. And so that's the basis for what you see with things like I'll just go to remove background. Okay, so this is a web service where you can upload an image and then they remove the background for you. And so this is freely available, but let's see if we can do this ourselves with Python. All right, so I'm going to go ahead and close those, and I have first example here is just going to be to scan a folder. So I'm going to import OS, and I'll import time as well. And I want glob. That's going to tell me what files are in that folder. And then I'll import from REMBG. We'll import remove, and then we'll get this PIL import. Okay, so Python image library will import image. Okay, we're going to create some directories to store the images. Here's our input and output. And then for each of these, I'm going to just make those directories. Okay, and if they're already there, then it'll just continue. Okay, so let's go through this while, I'll just go for 200 seconds here. I'm just going to scan every second and increment that. You could go while true here. Okay, and then it's just going to go indefinitely. But I'll just do it for 200 seconds just to, so it automatically closes after that amount of time. I'm going to get in the file path in, so in our input directory, if there are any images there, then we're going to process them and move them to the output. Okay, so for any files that I found, I'll print the file name, I'll open the image with PIL, and then I'll also remove the background. So this is the key statement right here that's going to enable us to remove the background. All right, I'll get the file name, I'll get the base name of the file, and then I'll save it to this output folder right here. All right, and then I'll remove the input folder image. Okay, so I'm going to delete that one. So this is all I need to be able to scan that. To run this, let's go ahead and create a virtual environment. So I don't necessarily want to downgrade all my packages. So I'll go here to this base, okay, this is the Anaconda prompt that I opened up, and I'll just change directory to the desktop. Make that a little bit bigger so it's easier to see. So here I'm going to go Python 3 and then virtual environment, and I'll call this background remove. Okay, so let's see. All I need to do instead of Python 3, I'll just do Python. I think on Linux and Mac OS I use Python 3. On Windows I still just use Python. And then what I'm going to do is just activate this. So if I come in here, I can see just a script that's going to allow me to activate it inside scripts. Okay, and it gives you some different options to activate it, but currently I don't have anything installed here. So what I need to do is just go ahead and change directory into the background remove, and then also scripts, and then I can activate. Okay, so it's going to activate. You can see right here, there's the virtual environment that it's created and is running in. And so now I can come back to solution 1. So this is scanning the folders. So we have any folders that are going to be showing up in, in this directory. I just have folder scan right here. And you'll see if I try to run this, Python folder scan, it's going to tell me that I have some missing packages. So rembg, it's not found. So let's go ahead and just do python-m pip install rembg. Alright, so it's going to collect these. It found some cached or stored packages that are there, and it's going to then set up this environment for me. Let's just go ahead and watch this, the libraries that it's creating here as it installs these. I guess there's nothing in the include. Okay, and then it's going to install them in this, and you'll see NumPy appears. So it's just kind of this minimal set of resources that we need to be able to distribute and deploy this application. Now this one will get just a little bit large because it's going to include quite a few of these packages that are listed here, and some of them are like TensorFlow packages, and others that are there for removing the background. So the authors of this package have greatly simplified the process of removing the background, with this rembg, but it has many other dependencies, as you can see right here. And you can see all of these are installing. You can see the Python image library, you can see SciPy, and some others as well. Okay, so all of these are getting installed. It takes a little bit to install these because some of them you have to compile. It'll run it for the first time. So it'll take a minute or two just to install these, and then once those are ready, then we can run the rembg. And what it's going to do is right here in this folder where I'm running it, it'll have an input folder that it creates and then an output folder. And any images that I drop here in the input, then it's going to then transfer them to the output. So if you wanted to, you could set this up even like in Dropbox, where you have this program running on your local machine logged into Dropbox, and you can then go onto another computer where you might have Dropbox also installed, drop them into the input folder, and then it'll automatically remove the background and transfer them to the output folder. So that's just an example of how you could change this application to be more of a web services type application. Okay, so finished with that. So let's see if we can run this now. Okay, so it's going to go folder scan. It's running every second. Just it's going to be checking. Okay, it's going to be checking for any input images. So let's go ahead and just input. I'll just do one of myself here. Okay, so in this folder, looks like it has not yet has to download a fairly large pre-trained TensorFlow model, and so sometimes that takes just a little bit of time. And I'll try to refresh this one. Oh, there's the input folder. Okay, so here's an image right here. I'm a coach for a running team. All right, so here is my output. Okay, and it went ahead and removed the background for that. So this is the full image right here. It has the foreground and the background, and it was able to correctly remove the background from that image. So pretty impressive. It worked. Let's go transfer some other images as well. So let's say we have maybe the image of a cat, okay? And we want to remove the background from that image. So you can see every second, oh, I just did coach again. Let me do cat instead. Okay, so there's cat, and you can see it. It's going to process it. It removes it after it finishes, and then you can see the cat. So it removed the, in this case, it removed the moon from behind the cat, and it was able to recognize what was the foreground there. Okay, so again, fairly impressive there. I'm going to do a photo. I'll do a photo of my family as well. Maybe we're processing this. There's something in the background. Okay. And so this is the beginning image. All right. And then let's go to the output. And there's the removed background. So you can see it missed some right here. There's a green background. It got most of it. It did a fairly good job. Just missed maybe one part that you might have to touch up with, something like Photoshop. So let's also try one more before our 200 seconds expires here. Here's a scientist, an engineer that we're going to be inviting to speak. And he's going to be coming, Juan J. de Pablo. And maybe I'm preparing something for his visit, an announcement, and I just want to remove the background. Okay, so you can see it did that really well just with this service that we created. All right, so that's solution number one. But let's see if we can create also a web service, okay, where we could do that with a local folder, but let's say we want to have this running. I'm going to go ahead and stop this. Okay, just did a couple Control C's just to stop it. All right, so let's say we want to have a web service where we want to have a server set up, or maybe a container or something like that we run on a web hosted service or on a bare metal server or on a virtual machine somewhere where we want to be able to run this. Okay, and then we want clients to be able to connect to this and be able to remove the background from the image. So I'm going to import async IO with WebSockets. Okay, I'll import IO PIL as well just to be able to open the image. I'm going to define a new function, the async function. This is going to be handling the image. And I'll do that with a WebSocket and a path. So I'm going to first of all await for the WebSocket to receive some bytes. And once it receives the bytes, then I'm going to open whatever came in with those image bytes. And I'll have to use io.bytes.io. Okay, then I'm going to remove the image background. And for that, I'm going to need this rembg. And so I'll do image equals remove, and there's our image. So that's the main service that I'm providing right there. And all this other part, that just handles the communication in and then the communication out as well. So let's look at our new image bytes. Okay, that's going to be IO bytes, and we will save, okay, new image bytes, and we'll do that as a PNG file. So that's to enable the transparency. You can't do that with JPEG or other formats. You have to have a PNG for removing the background, so there's transparency there for the parts that were removed. All right, and then we'll await WebSocket, and we'll send it. We'll send the new image bytes, and we'll get the value of that. Okay, let's go ahead and start our server, and we'll do that with WebSockets.serve, and this is the handle image. Okay, and we'll do that with localhost, and there's our port. You can change that if you want to do port 80, for example, or 443 for HTTPS. Okay, it's kind of the secure channel. So you can do any of those, and it will, okay. And then we have get event loop as well. We'll run until complete, and we'll start our server, and then just run forever. So we just want to run this forever, and let's go ahead and just do that. Okay, and you'll notice there's going to be one package that I haven't imported or installed yet. Okay, so instead of folder scan, this one's going to be server.py. So you can see WebSockets is not installed yet. So let's do that one. Pip install WebSockets. Okay, so that was fairly quick. And so now we've created a server. So this one is done. Okay, we just want to leave that one running because now we want to create a client that can then connect to that web server and send an image to the web server and then save it locally. So I'm going to move that one off screen. Let's go over to our client now. So we're also going to import async IO for this one, and we'll import WebSockets, and we'll also do the URL lib request, and that's just to download an image. Okay, I'll download this image and retrieve it to my computer. So that's the one that we're going to send to this web service. All right, we'll send an image and we'll connect to it through that port, the 8765 that I have defined there. If you change that, just change this port right here. Okay, we're going to open the image as a read binary, and we'll read that image, and then we'll send the image bytes. Okay, we're going to wait for the WebSocket to receive the response. Okay, so we'll send it, and then we'll wait for the new image bytes to come back in, and we'll save that as our new image. We'll write that also as binary. Okay, so we're going to run until complete. And we don't need to run forever. We just want to run once. Okay, so let's go to let's open up a new Anaconda prompt. And for this one, we don't necessarily need to create or activate our virtual environment. This one doesn't use the REMBG. So we could just run this from our base Anaconda distribution. Right, and I will also change directory into solution 2. And let's go ahead and just run this with Python, and then this will be our client.py. Okay, so again, no module named WebSockets. So I'll just go ahead and install that here. It's a different distribution of Python here. Okay, so pip install WebSockets. Okay, so it successfully installed it, and let's go ahead and run that now. And then you can see here, I don't know if you could see that change, but here is the input image that I had, and then it was able to remove the background. But it could have done that if, the server were running on a computer on the other side of the world. As long as I gave it the correct IP address and port, I could connect to that other service. So it's like, here's a service, I can connect to it with my client and then remove background images. Okay, so that's different than the folder one because it required me to place that image into the folder and then transferred it to the output folder. In this case, I'm running a web service like a server and just on my local computer just for demonstrations, but it could be on a separate computer. Or you could host the server on AWS or Azure or the Google Cloud platform. So any of those would work. Okay, so this was a little bit, just a little bit complicated for those that haven't worked with async IO before. But I'd say just don't focus on that part right here. This is just to input the image and then to send the image. Okay, so to receive and to send the image, this is the main thing that's our web service right there, to remove the background. All right, and then from the client side, we're just opening the image and then we wait for it, and send it, and then wait for the response from that web service, and then write the new image when we receive it back to the local computer. All right, so that's it for this tutorial exercise. on cloud access and cloud computing. We just created this, this simple web service to be able to remove background from images within the virtual environment, and came up with either the local folder option or the web API. So up next, we're going to be going through web scraping. So number 7 is the next one right in here. It's number 6 on the cloud, and then we'll get to more on data transfer. There's a little bit more on web sockets as well. We use web sockets here. So if you want to go back and review how to set up a web socket and be able to transfer data using web sockets, then come to this tutorial as well. I hope you've enjoyed that, and hope you also are able to get, in this data-driven engineering course, as you explore ways to be able to use data, curate data, set up data pipelines, transfer values, and data between computers. That's the whole purpose of data engineering and data-driven engineering.